Hello, this is BYU Math 112. In this video we will discuss textbook section 2.4, exercise something like number 7. We're not going to actually do number 7 and there's nothing comparable to it. So we're going to make up our own that's just like it. So the directions read, for the limit as x approaches 2 of x squared minus 4x plus 5 is equal to 1. Illustrate definition 2 by finding values of delta that correspond to epsilon equals 0.2 and epsilon equals 0.1. So we have our definition 2 here says, let f be a function defined on some open interval that contains the number a, except possibly at a itself. Then we say the limit of f of x as x approaches a is L, and we write the limit x approaches a, f of x equals L, if for every number epsilon greater than 0, there is a number delta greater than 0, such that if 0 is less than the absolute value of x minus a, less than delta, then the absolute value of f of x minus L is less than epsilon. That's a lot to swallow. So what is that saying? That says, as we are delta close to a with our x's, then we will be epsilon close to L with our f of x's. And if we can do that for every epsilon, find some delta, then that shows that our limit is approaching L for our function. Alright, so how does that translate into doing some work for number 7 exercise? Well, we're going to rewrite this part to make it look like this. That's our first step. So what does that mean? So if 0 less than x minus, what's our a in this case? A is 2, is less than delta. Then we know our f of x in this case is x squared minus 4x plus 5 minus L. Our limit in this case is 1. Less than epsilon. So we've got some given numbers for epsilon and we are going to find deltas. The general strategy is to look at this part right here and see how this part right here relates to this part right here. Okay, so we have x squared minus 4x plus 5 minus 1. What does that simplify to? X squared minus 4x plus 4. I have a quadratic equation there. Am I able to factor that? In this case, the answer is yes. In this case, the answer is yes. That factors into the quantity x minus 2 times x minus 2, or x minus 2 squared. Well, that's happy, because this x minus 2 sure looks a lot like that x minus 2 I have up there. And that's going to be very helpful to me in doing this problem. So when I look at the absolute value of x squared minus 4x plus 5 minus 1, that is equal to the absolute value of x minus 2 squared. And this is supposed to be less than epsilon. Well, with using our knowledge of algebra, we can take the square root of both sides. So the square root of the absolute value of x minus 2 squared is still less than the square root of epsilon. So we have x minus 2 is less than the square root of epsilon. Well, hopefully that looks familiar to you, as this same thing we had up here. X minus 2 is less than delta. So what are we going to choose? We are going to choose delta is equal to the square root of epsilon. And so up here on the top, if this part is true, if x minus 2 is less than delta, then if I square both sides of that, I can replace delta squared with epsilon. And I know that the other part is true. So for my values of epsilon, I'm going to choose delta equals the square root of epsilon. So for the first one, I know that epsilon is equal to 0.2. We evaluate the square root of 0.2, comes out to be somewhere in the ballpark of 0.447. And when epsilon is equal to 0.1, take the square root of that and we get something in the ballpark of 0.316. Please make sure if you're finding these deltas that you're rounding down and not up so that you don't go out of bounds on one side. This is a nice algebraic approach to figuring out delta given any epsilon. We want to use it anytime we're given a polynomial, is to figure out if we can factor that polynomial, as you'll do on number 7. My suggestion to you, factor it first so you see what you're working with. And since you know what a is, you can have some bounds on x to figure out what the bounds on each of those factors are. In this case, we lucked out that we had x minus 2 for both our factors. Example 4 in the book is a good one to look at if you don't have the same factor for each of them. But this is what we do with something like number 7. We rewrite it first. We use some algebra to factor the polynomial that's going to be less than epsilon. See how the factor for delta, x minus 2, plays into that. And see how we can compare delta to epsilon in some nice way.